Welcome to lecture series Design and Analysis of Algorithm. In today's lecture, we are going to see about an iterative improvement problem, which is Maxflow problem. So let us go to the lecture video. Now look at this figure. What do you infer from this figure? This figure represents the traffic in a given road system. And now look at another figure. What does this figure represents? The fluid flowing through a various pipes. This fluid can be water or any other fluid. And now look at this figure. What does this figure represent? This figure represents the electric current that is flowing to a given electric circuit. Similarly, we have another figure like a computer network which is laid down. Here, this figure represents the traffic or when the packets flow through a given computer network. So these all are some of the examples that contribute to the flow network problem. So flow network is nothing but a directed graph where each edge is associated with flow as well as capacity. So however, this flow network has a constraint that the flow should not exceed the capacity. So this is the definition of flow network. It is a directed graph where each edge has a capacity and each edge receives a flow. The amount of flow on an edge cannot exceed the capacity of the edge. So this is a constraint of flow network. So it should satisfy the restriction that the amount of flow that is going through a given node should be equal to the amount of flow that is coming out of that particular node. That is, inflow should be equal to the outflow. This condition is exempted for source and sink node, for wherein source node has only outflow and sink node has only inflow. Uh, so since the source node has only outgoing edges and no incoming edges, similarly, the target at the sink node has only incoming edges and there will not be any outgoing edges. The capacity represents the weight of the edge. So this Maxflow problem, it is an optimization problem. It involves finding the possible it does not involve finding the possible flows, but it involves finding the feasible flow through a given flow network from a single source to a single sink in such a way that the flow is maximized. This max flow problem can be solved using various algorithms. So in today's lecture, we are going to see how this max flow problem is solved using Ford-Fulkerson algorithm. Ford-Fulkerson algorithm can be represented like you are given a graph which represents a flow network where every edge is associated with a capacity and you have two specific nodes like source node and sink node. You want to find the maximum possible flow from that particular source node to the sink node, satisfying the constraint that the flow cannot exceed the capacity. And second constraint is the amount of inflow is always equal to the amount of outflow except the source and target. So this is the working of the algorithm. You will start with initial flow of 0 from the starting node. Whenever there is an augmenting path from source to sink, you will add the two paths and you will return the flow. So these are some of the terminologies that we use in flow networks like residual graph, residual capacity, minimum cut, and augmented path. So residual graph, it adds the additional possible flow in the graph. Residual capacity is the original capacity. And min cut is the maximum possible flow. So augmenting any path can be chosen as your augmenting path if it satisfies two conditions. That is, there should not be any full forward edges and there should not be any empty backward edges. Such edges can be considered as augmenting path. So now look at this example. Step 0 represents the initial flow network where each edge is associated with the capacity and initial flow is 0 for all the edges. So in the the first step we choose the augmenting path as SADT where the maximum flow permitted is 8. So in the next we choose the path SCDT where maximum flow permitted is 10. So total maximum flow by adding augmenting path will be 18. In the next step, we choose a path SCDABT where the max flow is 4. So adding to the previous flow, we get it 14. And next we choose SADBT where the flow permitted is 2. And last possible path that we choose is SCDBT, where the flow permitted is 1. And one, we still have paths left like SCDB and T, where the flow permitted is 1 we have seen earlier. So the final augmenting flow is 17. So the common use of flow networks is it is mainly used in computer networks where it is used to find the technological impact, modern lifestyle, advancing civilization, and flourishing networks. It is also used in network optimization where it is used to optimize a given network through innovative ideas. So here is one example for you to solve. For this particular flow network, you want to find the maximum flow from source vertex 0 to the target or sink vertex 5. So obviously for the I suppose the maximum flow for this particular graph would be 23. Please solve this problem and check your answer. Hope you understood what is flow network and what is max flow problem and the Ford-Fulkerson algorithm behind solving the max flow problem. Thanks for watching. We will meet in yet another video of design and analysis of algorithms. Thank you.